everyone. Thanks for joining us, and thank you to Neo4j for having us. Today, we're here to discuss G-Forces Meet Graphs, where we're going to take a look at building a graph model for sponsorship deals and seeing what that model can tell us about over 50 years of F1 sponsorship data using the GDS package. I'm Will Steadman, and I'm currently a business intelligence analyst for Delaware North, working primarily for the Cincinnati Reds unit. Most of you won't know Delaware North, but they handle the food and beverage operations at a lot of sporting venues. So I'm effectively a hot dog analyst. But today I'm joined by two real experts in the sports business field, Dr. David Tyler from UMass and Dr. Joe Cobbs from NKU. And he couldn't be here today, but Dr. Jonathan Jensen from Texas A&M also contributed pretty significantly to this research. Now on to the fun stuff. We're here to talk about two things. Firstly, F1, which is pretty cool. And secondly, graphs, which we all know are objectively cooler. So I want to start this off with a question. What makes F1 cars go? You might be thinking, easy answer, Will, that's gasoline. But I'm saying that's wrong. Maybe it's the drivers. They're the ones who press the pedal, but still not really the right answer. The real answer is money, and not this little paper and coin stuff, but like Scrooge McDuckian amounts of money. So now the natural next question is, how do teams make that money? You might say, well, they win races. And that's at most partially right. The real answer is they sell watches or hamburgers or energy drinks or, pump and dump crypto. And the money from all these companies comes in the form of sponsorship, which at its most basic level is just where a brand pays to be associated with a popular sports organization or team. There can be other benefits as well, but at its most basic level, that's what it is. So really what we're getting at here is that sponsorship is the financial engine that drives auto racing. It's what makes it work. And that led us to think, if we were consulting for teams, or if we were a marketing agency working for a team or a brand looking to get into the sport, what would we want to know that would give us a competitive advantage? A lot of what we wanted to know came down to understanding a team's sponsorship strategy. For example, we know that Aston Martin tends to pack on the sponsors on their car, whereas Haas tends to have just a few that they put in really prominent areas. That's the difference in strategy, but how do we dig deeper and take a more data-based, quantitative approach to analyzing sponsorship? Luckily, we had the data to answer these questions. Unluckily, it looked like this. And there was a realization that while we could technically store the sponsorship data in a relational database, doing any meaningful analysis on it would be an absolute nightmare. Good news for us is that not only would a graph database allow us to untangle that beast of an access file, but the native GDS package actually had built-in functions that could answer a lot of our questions for us. Like, which teams are most important in particular industries? We could take a look at node centrality in betweenness to see if Ferrari is at the middle of some tangled spider web that has luxury goods everywhere, or if the same's true about Haas and manufacturing. A lot of our questions could be answered by GDS, but even the ones that didn't have GDS algorithms that were immediately applicable could easily be answered within graph databases anyways. So right now you might be thinking that none of this is groundbreaking, but honestly, that's kind of the point we're trying to make here. A lot of this analysis could be done on relational data, but it's exponentially easier to do in graph. We might take hundreds of lines of Python code is reduced to 20 or so lines in one pre-built algorithm on the GDS package. And it doesn't take an AI machine learning savant to do it, although there are plenty of them talking today. But now, with our goals set and a sense of confidence far outpacing my actual abilities, it was time to start designing our sponsorship model. And luckily, we weren't starting from scratch. We built this model on the foundation of the No Rivalry Project database that David and Joe founded And if you're interested in learning more about that, feel free to check out the nodes presentation they did back in 2022. But all you need to know for now is that it has a node pre-built for every team, season, and sports squad, which is just the annual instance of a team that competes in that year's competition. Now, when you first think about it, making a sponsorship model and graph should be pretty simple. A company and a sports team come together and they make a deal. And that's not necessarily wrong, but it's a pretty rigid, inflexible framework that would be hard to build upon. So we realized we needed these intermediate nodes that we called deal squads that represent the negotiators, marketers, business people, and whoever else is representing the teams and the brands to get the deal done. This is a good start, but with this structure, we don't have any way to tie the deals to on-track teams or the sports squads whose cars carry the brand logo. To add this, we needed annual instances of the deals and deal squads. The annual deals allow us to tie the deal to the sports squad that benefited from the investment and hosted the sponsoring company. This also lets us connect it to team performance and see if that has an effect on the sponsorship. The deal squads also needed annual instances as the parties involved in making or maintaining a deal could change. Did the team or brand get a new chief marketing officer, and could that explain why a deal ended? The only way we can account for that is with that deal squad intermediate node. In fact, the only major part of our model that doesn't need an annual instance is the brand, as any changes to the brand that would be relevant to us can be captured in that year's deal squad. Another point is that each deal squad is unique to its deal, as different people or consultants could be involved. For example, it's safe to assume that it took Haas F1 a bigger effort to sign MoneyGram than it did for them to strike a deal with Haas Automation. So each of those deals gets their own deal squad nodes, the same way that the deals themselves are distinct. Finally, one of the biggest benefits we see to this model is its forward-facing flexibility. We haven't done so yet, but in the future, we can add nodes like a consultant or third-party marketing agency that can help us add in a whole nother layer of analysis, especially pertaining to why certain deals happen, or even who I should hire if I'm looking for a company that's had success brokering specific types of deals. Here's an example of just one of the over 3,000 deals that we have in the database. It's a simple 2-year contract between Ferrari and Veuve Clicquot that ran between the 2017 and 2018 seasons. Here's the core of the deal that remains the same throughout its duration. As we discussed, we now add in the deals and deal squads for each year. We can then tie the deals to the sports squads for the team from each year, which of course participate in that year's F1 competition. The only other thing that I want to call out here is that each brand is connected to an industry. In the case of Veuve Clicquot, that's the alcohol industry. And this becomes important when it comes to analyzing things like sponsorship strategy and whether teams are looking for exclusive sponsors in certain industries. And as you can see, we don't currently have any data on consultants or marketing agencies that are involved in these deals. But the point is that the graph has the flexibility that if we or someone else gets around to collecting that data, it can easily be added. So what did this look like in practice? Across 54 seasons, we found sponsorships for 719 of those annual sports squads, representing 82 unique current and former teams, which led to over 10,000 deal nodes, representing about 8,600 deal years across 3,300 unique deals. And these deals were conducted with nearly 2,000 brands, which represent 371 unique industries. After building this out, the analysis was as simple as making a few projections based on what we were interested in and plugging it into the right GDS algorithm. So you've seen the structure and the implementation. Now, what was the point of all this? What did we learn? Well, there were a lot of things, but there's a few we found particularly interesting that we want to highlight here. Firstly, most teams had remarkably similar sponsorship profiles. They pretty much all had a banking sponsor, a tech sponsor. Overall, it was pretty similar, except for Haas, which has remarkably few sponsors compared to the other teams, especially historically. But going back to sponsorship strategy, Haas is a machine tool company that might focus more on industrial partnerships. Well, there was a while that Racing Point's predecessor, Force India, had their team owner under arrest for fraud and unpaid debts, and we're adding a new sticker to the car for any company that could fork over a little money. With that aside, notably, none of the teams had over 85% similarity with another. So clearly, if you're a brand, there's going to be holes somewhere that you can fill. Secondly, many sponsors move in tandem. As a race team, these might be attractive targets. And if you add in agencies or drivers who might be sponsored to the deal squads, you should be able to dig down more into why this is happening and which brands you might be able to target as a potential 2-for-1. And the final thing I want to highlight here is that there was a shockingly high amount of non-exclusivity in sponsorships. What I mean by that is that some teams have multiple sponsors within the same industry. This is surprising as we tend to think of sponsors as wanting to say they're the official so-and-so of an F1 team, like how Guinness is the official beer of Newcastle United, or for our American football fans, Dude Wipes are the official sponsor of the Philadelphia Eagles tush push. As a brand or agency representing that brand, it would be helpful to know which teams have historically been more accepting of non-exclusivity before trying to negotiate a deal. So now you've heard about what we learned, but there's still a whole lot of things that we haven't learned yet that we can figure out with this model. Notable places to expand are considering on-track performance as a factor. We could learn things like if brands jump ship after a bad season, and if so, to what degree. We could also add in market cap for the sponsoring brands to try to see if there's a correlation between team success and high market cap industries. There's also more GDS analysis we could do. Two areas of particular interest are pathfinding to see if we can figure out a brand's sponsorship patterns over time, and community detection to see if we can find groups of sponsors with similar strategic patterns. Finally, and perhaps most importantly, how can we use this model for more than just F1 data? We're all massive sports fans and massive sports business nerds. So F1 sponsorship was a natural application for us, but we believe this model could be used for more than just F1 data and even taken beyond sports as well. Concert tour sponsorships, celebrity product endorsements, even more traditional B2B deals could potentially be framed using the same or similar model. We'll leave you all with those thoughts to chew on, but please, if you have any questions about the cypher or ideas on how to make this better, please reach out to us and let us know. We'd love to hear from you. And also check out No Rivalry. It's got some fascinating insights on sports rivalries, and you can contribute to make our database even bigger by taking the survey and letting us know who you think your favorite team's biggest rivals are. So thank you everyone for coming to our talk. And one more time, thank you to my co-authors, David and Joe, and to Neo4j for having us.